So, yeah, welcome. And today I would like to give you some updated information about what's happening at AMSAT DL. Unfortunately, at the moment we don't have any phase 3 satellite up there, which is not so nice for our ham radio activities, but let's see, we come to that more later. So anyhow, during the last couple of years we had a lot of talks to find funding for the Mars mission, and certainly this funding cannot come from the amateur radio community. That was always clear, although sometimes people do not got this message. It's perhaps the other way around. The Mars mission hopefully will enable us to fly another phase 3 satellite. Anyhow, so I hope this works. Yeah, meanwhile, there are almost 25 years with AMSAT services around Earth, and even one of our favorite launch agencies want to see us flying to Mars, and they already offered if we fly to Mars, they will also take phase 3E. So, as you know from the geometry, there's a lot of distance between Earth and Mars, so signals will be very weak. That means we need to have very good receiving capability on the Earth and also on the orbiter. That means from the Earth to Mars we need a lot of uplink power, and the other way around probably too, but a good receiving station. So to realize this, we were very lucky. You heard about our 20-meter dish in Bochum. This dish has a long and interesting history, and we all are talking about Apollo recently. This dish was operated by the famous Professor Kaminsky, and it was used to record voice and communication from Apollo 11. And actually, we also talked about balloons. I really like the teddy bears. And there's a funny story about this. I come to our EVE experiment, the Venus echoes, right after this. A week ago, our team members in Bochum had a funny idea because of the history of the Bochum dish and the anniversary of the Apollo moon landing. They thought to launch a balloon, similar to like you did. So they had this kind of meteorological balloons, and they put a small box on it with a 2-meter transmitter and an MP3 player. And this MP3 player was actually playing the original sound recorded with the 20-meter Bochum dish during the moon landing. So the famous words from Buzz Aldrin. And so this was recorded on this MP3 player and played while the balloon was on its way. A lot of media interest from the local media, not too much, but still was okay. The launch was live transmitted in the local television, and also a lot of radio amateurs received the signal, so it was quite successful. And this balloon landed on the coast of Norway, so quite a long distance. What our friends forgot to put, they had made unfortunately I don't have photos with me, but they made a nice box with a lot of stickers, Apollo, the Eagle, and so on, and it was saying this was Apollo 40 for 40 years, but they forgot to put a letter on it where it is originating from. So the balloon landed on the coast of Norway, and a small children, they found this box. Wow, what is this? Apollo, and so on. And nobody knew what it is, and it went to the local media. Mystery object found. But one of the newspaper readers, he Googled around and actually found that this balloon was originating from Bochum. And so it went to all the press agencies, you can imagine. A big hype, and television stations coming again to Bochum. the head of Bochum city, congratulations, and other ministry members, congratulations. So without intention, this was just by incident. So sometimes this is frustrating to see how simple things can attract a lot of people, and the big things, indeed, it's more to the scientific community, no interest at all in the media. We had a similar experience. Here you see some pictures from the inside of our Bochum dish. I think you have seen that before. So why do we have this 20-meter dish? Indeed, we need, as you have seen before, we need a big receiving and transmitter to communicate with the P5A mission. And as I said, the dish was used before during the Apollo missions, and since then there has been not so much activity, and all the electronics was complete old and not working anymore. So everything was completely renewed, including all the mechanics, the motors to move the dish, because the dish wasn't working anymore. But all this was done with our keen members, Karl, Mainzer, James Miller indeed. So a lot of work was done on the hardware side and also in software for really high accurate pointing of the antenna. So we can move and we can track any object from Earth objects to interplanetary probes, planets, everything. And completely by remote control. So one of the first things we did was the successful reception of the Voyager 1 probe in March 2006 at a distance of 14.7 billion kilometers. So you can imagine this was quite an achievement. So we sent a QSL card to the JPL, to the Voyager team, and they were really surprised. That was the first time that outside of their DSN network, any other station was successfully receiving their signal. So we got a nice photo. This photo basically with our QSL card and all the team members still operating the probe. The next thing we did was what we are doing now at the moment. So one reason why we did this, why we received Voyager and also other Martian probes, was to demonstrate, yes, we have the capability to receive extremely weak signals, so receiving P5A will not be a problem for us. Also to demonstrate that we can do this on a daily basis, even by remote control. A couple of months ago, a team from NOAA sent a mail around. We are looking for help. So they have launched the Stereo A and Stereo B satellites. So Stereo A means ahead of Earth, and Stereo B is behind Earth. And both spacecraft looking at the sun, so they can more or less get a three-dimensional image of the sun, and in particular looking for sun activity, outbreaks, and so on. Unfortunately, at the moment, the sun is very quiet, but nevertheless, in the past, they were mostly relying on the deep space network from NASA to receive telemetry from those satellites. And you can imagine there are a lot of interplanetary and other probes around, and so they only have a very short slot to actually receiving signals from these probes. So NOAA actually needs more telemetry and more real-time data, so they send out this message for help for stations having dishes in the area of 10 to 20 meters. So we got the idea, why not trying to give some help. So what you see here on the left side, so on this, oops, I think the battery is empty. Yeah, okay, sorry. So there's an internet address where you can look at the beacon coverage. That means, Aha.
Top one button.
This one?
Top one, yeah.
Top one. So at the moment, there are 5 stations worldwide receiving data from the stereo probes. So we have here one in Chilburton. Also, they have recently withdrawn for some reason, which I show you later. Then there's another station in Koganai, Japan. Then we have a center, the CNES in Toulouse, France. Then we have an amateur station, DL0SHF in Kiel, northern Germany. And we have the AMSAT DL dish in Bochum. And here you see a drawing about the time of the day, from 12 hours to 18 hours, for example. And this shows, so blue is the stereo B, and red is stereo A. So depending on the time and the position of the Earth, the stations will have different views of the satellites. So here you see Bochum, stereo B and A, Kiel, nothing from Toulouse, Koganai, yeah, a little bit, Chilburton, nothing, and this is a deep space network. So you can see Kiel and Bochum really at the moment supply a lot of telemetry data for them. And the result are images and also a lot of data which you can see at their website. So we are operating this Bochum dish now continuously, I think for the last 2 months, to demonstrate that our station is actually really capable to autonomously do such kind of application, receiving telemetry and so on. And besides this, I think we are not, unfortunately, we are not paid for this. I think DSN got a lot of money, we don't. Same applies for our colleagues in Kiel. They do it for educational purposes. They get a little bit money from the university, but still, we hope maybe someone will come up and give us some money for the thing we are doing. But we have to remember that we radio amateurs also depend on the solar activity, and I think even for us, with some scientific background, we might be very interested in seeing this data and knowing that we amateurs also take a big part of that. Yeah, page up. This is actually a diagram of the data as it is received on the central server in the United States, operated by NOAA. So similar what we have done before, say with Oscar 40, where we had a lot of stations around gathering telemetry, sending it to a central server. They do a similar thing here with the scientific data. So they receive the data from the various ground stations, for example, Chilburton, Toulouse, Kiel, Bochum, and so on, and merge this data together to get really a good coverage. And on this diagram, you could actually see the quality of the data. And for example, this is a deep space network. Here you can see Chilburton, and you can see, obviously, I don't know what kind of antenna they are using. Probably is
4.5 meters.
4
4.5 meters.
So yes, they have a 4.5 meter dish, so somehow they have the limit. Maybe some improvement can be done.
Well, there's a 4.5 and there's a 2.5. I think this was probably taken with the 2.5, because I think the 2.5 is tracking to it's actually A enough.
Okay, so we had a comment here that Chilburton may use a 2.5 meter dish, or at least a small antenna compared to Bochum, and that's why they're having a lot of problems here, and finally they decided to withdraw for the moment. And also you can see here Bochum. Now this is Kiel and this is Bochum, and you see here, for example, we are really receiving here really 100% quality, and indeed with a 20 meter dish and this short distance, not a surprise. Yeah. One of the good things is what makes the difference between us and Kiel is using another dish now to receive stereo A and B. So there is also a little competition going on between Bochum and Kiel. So Kiel is now ahead since they are able to receive both satellites. our next step is James Miller made an improvement, because at the moment all those stations basically use the same software. It's a Linux software and a software decoder running using a sound card. And James Miller recently started to make a demodulator, improved demodulator with much better efficiency, as you can imagine, James style. So at least everyone can see, yes, we have the receiving capability. Now let's talk about transmitting. Yeah, when we designed the dish and all the capabilities needed for our Mars mission, Karl Mainzer also got the idea, hey, there's also Venus. And every couple of years, Venus comes very close to the Earth, and this happened on the 27th of March this year. So the distance was only 42 million kilometers. And so why not trying to transmit a high-power signal to Venus and look for the echoes? Actually, we have done that before. We tried that a couple of years ago. Some of you might remember on 10 gigahertz expand without success. And there's a theory that the atmosphere of Venus will not allow much energy to be reflected from the surface on expand. So, but he calculated that on 2.4 gigahertz it should work. So he made all the calculations, and finally, I think 0.3 dB of his predictions. So actually, if you transmit a signal from Earth to Venus, it takes about 5 minutes. And finally, you see here the signal as it comes on our spectrum display from the software written by one of the colleagues here. I think it's, who is it? Here's this guy. I forgot his call sign, but some of you might know very well. So he wrote the software for all the DSP processing, integration of the signal. So we had really a clear peak of the echoes received from Venus. There's a video which I would like to show you now. For those who would like to see it again, you can find it on our YouTube and also on uk.7load.com under the user AMSAT or AMSAT DL. Unfortunately, this video is in German, but I hope you get a little feeling about the exciting of this experiment, the excitement.
Sind es Spinner, Phantasten oder ernstzunehmende Forscher? In Marburg wird gerade an einer Mission zum Mars getüftelt, mit kleinem Budget und abenteuerlichen Materialien. Am Ende aber steht vielleicht die weltweit erste private Mission zum Mars. Die Tüftler sind die Mitglieder von AMSAT, einem Zusammenschluss von Amateurfunkern. Kernstück der Mission ist ein Hochleistungssender, gebaut im eigenen Marburger Labor.
Seid ihr da weg in Sicherheit?
Beim letzten Versuch war ihnen einiges um die Ohren geflogen. Jetzt scheint es zu klappen, den Sender hochzufahren. Der Sender, das ist die Kiste. Ein Experiment mit 5000 Watt. Kommen Sie bloß nicht dran, warnen sie, sonst reicht ein Kehrblech für Ihre Reste. Aber auch ohne die freundliche Warnung reicht die Anspannung.
Ach nee, ich muss ja hier 1,2 einstellen. Aber das ist besser geworden. Das ist, es wackelt auch ein bisschen, aber es hat auch jetzt nicht mehr gezischt. Ne?
Karl Mainzer ist zufrieden.
Ist viel besser. Ja.
Das Blech hat das gebracht. Ja.
Mit dem Sender wollen sie den Mars erobern. Ganz ernsthaft und zielstrebig. Das Modell der eigenen Raumsonde hängt schon lange bei AMSAT in Marburg. Hier werden seit Jahren Satelliten gebaut, mit großem Erfolg. 4 umkreisen inzwischen die Erde, gebaut von Amateurfunkern für Amateurfunker. Ehrenamtlich, Geld verdient keiner. Die Mars-Mission soll die Krönung sein, nur kosten darf sie nicht viel. Not macht erfinderisch.
Das ist ein Teil aus der Autobranche, und zwar ist das ein Kühler aus dem Polo.
Das ist eine typische Lösung, die eigentlich AMSAT-typisch ist. Wir haben also alles Mögliche, auch selbst die Senderöhre ist ja eigentlich eine Röhre, die nicht für Sender gedacht ist, sondern um in industriellen Anlagen zum Beispiel Tapeten zu trocknen oder ähnliche Sachen zu machen und nicht um damit zum Mars zu funken.
Gleiches gilt für den Staubsauger, der die Röhre kühlt.
Also mit wenig Kohle machen wir viel Energie.
Gut ein Jahr haben sie an dem Hochleistungssender gebaut und technisches Neuland betreten. Im Laden gibt es sowas nicht. Die Schaltpläne hat Karl Mainzer geschrieben. Marburger Elektronikprofessor im Ruhestand. Kopf der Tüftler, für den es keinen Zweifel gibt, dass sie hier die Kompetenz haben für die weltweit erste private Mars-Mission. Das bestätigt auch die NASA.
42, 580, 6 Stellen.
Der Sender funkt. So viel ist inzwischen klar, nur nicht auf der Frequenz, auf der er soll.
Hast du das falsche Seitenband, oder?
Nee, sagt Freddy die Gürtener, der Funkspezialist. Also greift Mainzer etwas unkonventionell in die Steuerung.
Ich greife mit der Pinzette etwas Frequenz daraus, die jetzt hier durch mich als Antenne abgestrahlt wird und dort in dem Empfänger landet, damit wir die Frequenz messen können, die hier rauskommt. Sie sind die Antenne? Ich bin jetzt im Moment die Antenne, ja. Warum hört man denn gar nichts? Ich höre gar kein SSB-Signal.
Aber dann, plötzlich. Es rauscht, der Computer empfängt den Sender. Noch mit Karl Mainzer als Antenne, aber egal. Es funktioniert. Und die Zeit läuft ihnen weg. AMSAT-Mitglieder warten schon. Jetzt muss der 160 Kilo schwere Sender mit dem LKW nach Bochum, um heute noch montiert zu werden. Hier in der Sternwarte hat AMSAT die Bodenstation für die Mars-Mission eingerichtet. Der Marburger Sender ist das Kernstück. Nur mit der Montage wird dann doch nichts mehr. Im Radom, so heißt die Kugel, ist es inzwischen zu dunkel und die Arbeit sowieso schon gefährlich genug. Morgen werden sie weitermachen und dann die Venus anfunken als ersten Test.
Gestern haben wir über die Männer von AMSAT aus Marburg berichtet, einer Vereinigung von Funkamateuren, die die weltweit erste private Mission zum Mars starten wollen. Dazu brauchen sie einen starken Sender. Den haben sie zusammengebaut und in ihrer Bodenstation in Bochum aufgestellt. Heute nun haben sie etwas ganz Besonderes vor. Sie wollen zunächst einmal den Planeten Venus anfunken, der 45 Millionen Kilometer weit weg ist. Ob dieses Experiment klappt?
James, please go.
Okay, here we go.
Ja.
And go.
140 Tonnen drehen sich in Position. Wir sind in der Bochumer Sternwarte, der Bodenstation von AMSAT.
Sie sind synchronisiert, jetzt ist da.
Die Idee ist so verrückt, dass es vor ihnen noch kein Europäer versucht hat. Die Venus wollen sie anfunken als Test. Der erste Versuch allerdings eine Art Fehlstart.
Wahrscheinlich haben wir irgendwas falsch gemacht. Eines der Probleme ist, dass wir erstmal lernen müssen, diese ganze komplizierte Maschinerie überhaupt selbst zu bedienen, weil das sind so viele Bedienungselemente, die hier falsch eingestellt sein können, dass sowas immer mal passieren kann.
Karl Mainzer hat den Hochleistungssender in Marburg entwickelt. Viel Zeit zum Testen hatten sie nicht.
So, wir können.
Bochum vor ein paar Tagen. Der Sender, an dem die ganze Mission hängt, hängt am Haken. Ein Prototyp, made in Marburg. Er ist das neue Herz der riesigen Antenne. 20 Meter Durchmesser hat die Schüssel. Jetzt werden sie Neuland betreten und nebenbei die Europäische Weltraumorganisation ESA überholen.
Die Befriedigung nachher, dass man Dinge getan hat, die die Kommerziellen teilweise gar nicht können oder mit unglaublichem Aufwand können, die rechtfertigt doch vieles.
Sie sind alle Amateurfunker, wobei man das Wort Amateur getrost streichen kann. Sie wollen von hier eine Raumsonde zum Mars steuern, ganz ernsthaft. Und dafür muss die zugegebenermaßen alte Parabolantenne auf Hightech getrimmt werden. 10.000 € durfte der Marburger Hochleistungssender kosten, deshalb kühlt ein blauer Staubsauger die Senderöhre. Der Etat unterscheidet sie von den großen Weltraumorganisationen. Hier soll die Kiste montiert werden. 30 Meter über dem Boden im Zentrum der Riesenantenne.
Wir können den Sender einfach an die Seiten hier hinstellen. Ja.
Freddy de Gürtener, AMSAT-Kollege aus Belgien, ist verantwortlich für den Einbau. Er hat den Sender mitgebaut in Marburg. 160 Kilo wiegt die Kiste, unmöglich sie einfach reinzutragen ins Loch. Deshalb haben sie sich einen Trick überlegt. Die 140-Tonnen-Schüssel wird einfach flachgelegt, drüber gestülpt. So verschwindet der Sender automatisch im Inneren. Und auch wenn sie schon oft in der fahrenden Antenne gestanden haben, ein komisches Gefühl ist es doch immer wieder, sagt Freddy.
Okay. Michael, Füße sind weg?
Ist alles weg.
Okay. Also pass auf, der knallt hier runter.
Ja.
Jetzt.
Okay, ich lasse mal einfach kommen.
Optimal.
Jetzt muss er noch verschraubt werden. X Kabel müssen sie verlegen. Tage werden sie damit zu tun haben. Aber dann ist es soweit, dass sie sich mit der Schüssel im Raddom, so heißt die runde Traglufthalle, den Himmel ein gewaltiges Stück näher holen. Jetzt zweiter Versuch, die Venus anzufunken. Wenn das klappt, klappt auch die Mars-Mission.
Stopp.
Und sie konnten der NASA helfen bei ihrer Mission.
Es ist sehr schwer möglich, vom Marsboden direkt die Daten zur Erde zu bekommen. Und es ist immer eine Mangelware, auch heute noch sozusagen eine Telefonzelle da um Mars zu haben, mit dem man dann zur Erde telefonieren kann. Da haben wir also unmittelbar einen direkten Nutzen für ein solches Raumfahrzeug gesehen. Und ich denke, der Bedarf besteht nach wie vor. Das heißt, diese Funktion werden wir erfüllen.
Wenn der Sender funktioniert. Ein Funksignal haben sie zur Venus geschickt, denn die ist gerade in der Nähe, nur 45 Millionen Kilometer von der Erde entfernt. 2,5 Minuten braucht das Signal zum Nachbarstern, wird dort reflektiert und
Jetzt kommt's.
Das sieht
die rote Linie, das ist die Venus. Sie haben es geschafft.
Mir geht's gut. Mir geht's gut. Das funktioniert jetzt. Also das ist doch ein schönes Ergebnis.
Jetzt können sie mitspielen im Kreis der Erlauchten, der Weltraumorganisationen.
Eigentlich haben wir jetzt alle Technologieelemente für die Mission im Griff, weil alles andere haben wir vorher schon gezeigt, dass wir das können und haben. Und es geht jetzt eigentlich nur noch darum, dass wir die Mittel kriegen, die Mission wirklich zu bauen und dann auch durchzuführen.
Gerade mal 20 Millionen Euro fehlen ihnen noch für die Marburger Mars-Mission. NASA und Co. haben abgewunken. Das sei ihnen zu billig.
Okay, sorry that this is not yet dubbed in English, but we had an offer that one of our members will probably underlie this video with English titles. So the last words Carl was saying is that we basically, with this EVE, we demonstrated that we have the capability to communicate with the spacecraft in Mars orbit. And so basically what we only need is the money to actually do it. And in the last word of the commentator was, because Carl, the price tag for the P5A mission is 20 million euro, which is compared to what we have seen before, not really much. And so unfortunately, somehow the reaction is a normal probe in the normal business would cost maybe a magnitude or more, 500 million, who knows. And we cost only 20 million. So our politician says, for 20 million this cannot work. I mean, we all know these problems from our amateur satellites, from the OSCE series. I mean, in the past, the commercials, how did they look at it? They are amateurs, and this will not work. And now, even with the CubeSats, we see that that's really, we are going into new dimensions. And so, the same here with our Mars mission, indeed. But there is one thing I would also like to show you, if I get this working again. So how to make it full view. Sorry. Zoom to actual size. I did not use, I think this button probably is the right one. No? Okay, it should work anyway. So, very often we hear the question, okay, what is about amateur radio in this mission? And yes, we have this 20-meter dish in Bochum, but indeed this is necessary to communicate with the spacecraft even during emergency if the link budget to the spacecraft is not as good as it could be to secure communication even under worst case But will it be possible to receive our P5A spacecraft with ham radio equipment? And the answer is yes. I think last year Achim, the H2VA, gave a presentation about how big must your antenna be. And because you have seen that before, every 200, so this is a distance here, 270 days, so we have a period of 9 months out of a 26 months period where Mars comes very close to the Earth. And he made some calculations, and in principle, even with a 30 centimeter dish, it might be possible to receive P5A. But I think even a 20 centimeter dish is something which is in the outreach of probably not every amateur, but most amateurs. So amateurs will be capable to receive P5A. They will be able to log to the signal and also decode some telemetry. They will not be able to make a QSO, that's clear. So there will not be a linear transponder on P5A. But it was quite fascinating for me. Last year on the ham radio in Friedrichshafen, we talked a lot about the Mars mission, and it was interesting. We got a lot of youngsters coming to our booth and asking questions. They were also ham radio interested, but they were more interested in the Mars mission rather than P3E, which was also interesting to see. So I think it's quite a sort of challenge, imagination, communicate with a spacecraft around Mars orbit and just thinking about it. So, but anyhow, the message I wanted to give you is, yes, there is something where also the normal amateur can play with, even if we go to Mars. So, one of the things we want to do is to use P5A as a communication relay for other satellites around Mars, also in particular for landers to improve the communication capabilities to Earth. And also P5A will have its own experiments. I will talk about this also in a moment. So for example, you have seen a lot of coverage in the media about Phoenix, but most of you probably don't know all the data, all the images you have seen, the spectacular images, were not sent directly to Earth. Phoenix only had an UHF transmitter on 401.58 megahertz, and all what we got was relayed through Mars Odyssey, Reconnaissance Orbiter, and Mars Express. So something we also plan to do with P5A, because they had the choice to have a high power transmitter on the lander, but because of every weight, every kilogram is very important, because every kilogram you need more for communication, something else you cannot use for scientific purposes. So they decided to have less weight for communication, but more capability in science. Okay, so these were a few more. Now I will start. I have to go to the beginning of my. Does someone know how it works to make a full view? Page display?
Yeah, full screen mode.
Full screen mode. Ah, thank you. That was the one I was looking for. Okay, let's talk a little bit about Phase 3E. Also, we are talking quite a long time, and sometimes I'm getting bored to talk about this and having not so many news. But anyway, so why do we want to make Phase 3E? As we have seen earlier today, the high elliptical orbit has a lot of advantages, in particular regarding the long range and long duration communication performance it provides. And after Oscar 10 and Oscar 13 and also Oscar 40, none of those which is operating now, we see the need for another phase 3 spacecraft in a high elliptical orbit, in particular to bring back the fun of Oscar 10, Oscar 13 and also Oscar 40 to the AMSAT community, and probably also, not probably, but also to get more amateurs involved into that. I mean, we have seen after the success of Oscar 10 and Oscar 13, for example, there was a big wave. I mean, we all know about this. We also have seen this in our number of members of the AMSAT organization, what happened. So indeed, it would be nice to have another such kind of phase 3 spacecraft in orbit. And due to the high elliptical orbit, as I said, you have a long duration, not only a long footprint, but also a very long duration, because the spacecraft, most of the time, the spacecraft will be staying in the apogee. So compared to the MEO, yes, from a viewpoint or from a point of the view, it's also the duration you have, because the spacecraft is staying a long time in the apogee. Also, yeah, why do we use the same structure again? This is a well-known phase 3 structure, as you know, from P3A, which never reached orbit, Oscar 10 and Oscar 13, because this is for us the cheapest way to get there, because we do not need any extra qualification. The spacecraft structure, the bus, adapters, propulsion system, and all involved safety issues, everything was done before. So there are no extra qualifications necessary. Another reason is we wanted to reuse most of the existing improved technology. Indeed, we also have some lessons learned, so there's always room for improvement. And from the point of view, this kind of phase 3 spacecraft or structure is the optimum bus for spacecraft in HEO. And we have minimum resources actually to do this project. So again, about the orbit, we are talking about a high elliptical orbit, with high inclination, about 50 degrees inclination compared to the equator. The perigee should be 2,000 kilometers and apogee 44,000 kilometers. This will give you a 14-hour period. That means every 7 days the apogee is over the same location on the Earth. That means more or less you can make a planning on Saturdays. I know the spacecraft is there and I can communicate with Japan, for example. And indeed, depending on where you are living in the Northern Hemisphere, this can give you up to 100 hours of coverage every week. So there's plenty of time. You do not need movable antennas. You can... Oops. Thank you for using our product. Yeah, please give me money. Okay, so I think this is out of question. Yes, I think we want another HEO. We made some surveys in United States. AMSAT NA made a survey. We did a survey, and I think, yeah, everyone wants to have another HEO spacecraft. In Germany also, that was in July 2002, we also included in our survey if our membership is interested in interplanetary probes, meaning the P5A, and at least there were more people interested in the P5A rather than in a LEO spacecraft. Also, this might have changed since then, 2002. It's quite a while ago. Okay, we leave that out. So what is the current P3E status about the spacecraft itself? Basically, it's the same status we had last year. All the mechanical work is done. We have the propellant tanks. They are qualified and integrated. We have the batteries qualified and selected. They are ready for integration. if I say integration, that means for flight integration. At the moment, there is no reason to put them into the spacecraft because there are other things to do. So, but basically they are sitting aside. Antennas are ready, microwave antennas, sun and earth sensors are already integrated into the spacecraft structure. The solar generators are ready. We have them, the magnetic system for the magnet talkers to do the attitude control when the spacecraft is in perigee is ready, already integrated. And the wiring harness for the various modules is also completed. Also, you heard about this CAN bus we are using in the spacecraft for control and telemetry with the various modules in the spacecraft. These modules are tested and also distributed to the module builders. Some of the modules are already in Marburg, so this is also closed action. Also important is this clamp band, which is used to clamp down the spacecraft on the flight on the adapter on the rocket. Normally this is a very expensive one if you have to buy it, but we made this with our own resources. So we built that ourselves in our machine shop and also with help of external companies. Also the flight, the apogee motor is tested and ready for integration. Also the helium bottle and a lot of all these little items you need are ready for it. So basically all the mechanical work is completed. One of the problems we currently have is the IHU3. This is our integrated housekeeping unit or the onboard computer, a new generation which we developed together with our friends in AMSAT NA, but unfortunately due to the ITAR regulations, development in the United States has completely stopped, and we were in a limbo state for a little while, but fortunately in the meantime we found some of our own members who is now going to continue the work on this IHU. So most of the development and research was done by Karl Mainzer, but now we have to go into the real coding and the real work, but it will still take some time. Regarding transponders, Howard is here indeed with SDX Stellar. So yeah, we have some delays in the transponders, but at the moment I can say everything is on track. Other parts are already delivered, the LS front end and also P5A, the current linear, the test transponder. This P5A unit here, that is actually another unit which will be used to simulate the conditions when we communicate to P5A in Mars orbit. We have some kind of simulator for doing the same with the spacecraft in Earth orbit, just to prove that the kind of communication we are using, the protocols, forward error correction, encoding of the signal will work. And that is also another reason why we want P3E together with P5A, is that P3E is used as a test bed also for the P5A mission. So one of the biggest problems at the moment is to find a launch opportunity. A while ago we had a serious offer to fly on another Ariane 5 launch. Actually the launch happened very recently. That was this TerraStar 1 satellite. That was a single launch on Ariane 5. But still they wanted a lot of money for that launch. In general the problem is there are no more test flights with Ariane 5. I don't remember how many successful flights there have been in between, but there are a lot. And yeah, it's like a production. Get the satellites together, put them on the rocket, launch. Next to launch, next to launch. Always you see this double launch configuration. So this is more or less a standard configuration. So they have nothing to do, no more qualifications, no studies or analysis about flight passes. Basically, it's really getting them up on the row, only waiting for the big customers. And if we want to put, say, phase 3 on such a launch as an additional payload, they have to make new studies, they have to make new calculations to see what will be the impact, and they have to give this away to external companies to make such kind of studies, and they will, even only for a little bit of paper, this will cost millions. So that's the reason why it costs so much money. TerraStar would have been a little bit different, because for TerraStar that is a single launch, and Ariane 5 was not designed for single launches. So for this kind of launches they had to make an extra study which costs a lot of money. Some of the money probably they would have taken from us, because even if we want to be included in this one, is a problem. It's, as I said, there are no qualification flights. So the nominal price for going into GTO these days, a couple of years ago we talked about 10,000, nowadays it's 20,000 euro per kilogram. So instead what you see is, if you look on the market, the prices go up instead of down. It's at least with the big launches. So our conclusion was, if we talk about the standard Ariane 5 launch with a standard contract, even if we get some clever negotiations, and we have a lot of friends in Arianespace, but they have to make business. So this is even still a magnitude too expensive for us. Another possibility or option we were looking into it was Soyuz. Soyuz should have been already launched from Kourou, so they also have a lot of delays. I think the plan is now end of this year or probably early next year. Our hope indeed was that this will be a test flight, so we were also invited to customer seminar in Kourou, and also we visited in June 2007 the Samara Space Center. That is where the Soyuz rocket is built, and we had a lot of discussions, but unfortunately there's a lot of competition going on, and right now the plan is that the first launch from Soyuz will be a commercial flight and not a test flight, and they have already commercial passengers taking the risk. We have to see how this will finally come out. Maybe some of them will get cold feet, who knows. So I would not say we have no chance, so we have to see about the first launch from Kourou what will happen. Indeed, another possibility we are looking into the SpaceX. We had a visit from SpaceX representatives in Marburg. We showed them how we are doing our projects. They showed us how they are doing it, and it was quite interesting, fascinating to see that both sides had the same ideas in mind, the same way to do it. So using make as much as you can yourself. Do not try to buy something from external companies, because very often those parts will fail. So try to do as much as you can by yourself, and that's, I think, also one of the things SpaceX. And also, it's my understanding or feeling that sometimes the commercial industry or professionals look at us, we are amateurs. In German, especially in the German language, the word amateur has a very negative, I don't know, I think it's in most countries. But when we talk about this, we have a big fortune, and that is, amateur comes from French and means love. Yeah. So I think we have a lot of passion doing this kind of project, and I think this is a real advantage. We love to do these kind of things. So anyhow, so for later this year we plan to have another visit in United States with SpaceX, and to discuss our ideas with Elon Musk. And we know that Elon Musk is also very interested in Mars. I don't know if you know, but that's why actually Mars is the reason why SpaceX was created, because Elon Musk, as you know, he got a lot of money from the internet hype and internet age, and he wanted to send his own spacecraft to Mars and plant a palm tree on Mars. And he tried to find out, okay, he found out with the money he has, he can build a satellite, and but he needed a launch. And so he contacted the same launch agency we contacted and found out, ooh, they want a lot of money for it, too much money. Then there came the idea of, okay, the Russians having cheap launches. But once the Russians found out that he has a lot of money, the price tag also went up. Yeah, and then that was basically his idea, okay, then I have to also build my own rocket. Yeah, very similar approach like our teddy bears, I think. Start from scratch. So anyway, yeah, we hope to have a meeting later on and find some interest and see what are the capabilities and what are the ideas, and we have to see what comes out of this. We are, at least I can say, both sides were quite optimistic about this meeting, and both sides were very impressed what the others are doing and how they are doing it. Yeah, okay, so talking about the funding and efforts in general, I know, or you already know, attractivity of amateur radio has dropped in general. I mean, yes, we have mobile phones, we have the internet, so it's getting more and more difficult to convince people or demonstrate what is so special about what we are doing. And also we found that funding such a satellite from amateur resources alone, I'm talking about phase 3E, not about P5A, from amateur resources, seems not to work at the moment because the funding is much behind. If you really want to get a launch, we cannot get the funding from amateur resources. In the past, with Oscar 10, Oscar 13, we always had the fortune that the launches were quite cheap, not always for free, but we got support from government. But nowadays, if we go with an amateur radio satellite to our government and tell them what we are doing, and they say, okay, yeah, nice satellite, but we have so many satellites now in orbit, this is nothing special, nothing like the area when we had Oscar 10 and Oscar 13. That really was something front of the technology. So promotion by governmental agencies is very, very difficult. So our consequence of this was, and especially by Karl Meinsam, I must say, now I know why, that we have to try to get funding through our Mars mission. So the idea is that we file an application to the DLR and get promotion for this P5A mission, and that P3E will fly as an experimental test platform for the P5A technology, including ham radio indeed. So our application of P5A, including P3E, which we submitted, is in the order of 20 million euro, which is quite cheap, but it is possible to do it. So about 10 million, the calculation goes for building the satellites for 10 million euro and having them also launched for 10 million euro. We already had some meetings with DLR, and finally the first step is done. We have won a study, a survey, which will be performed together by DLR and AMSAT about modification of the phase 3D bus to fly to the moon and also to Mars. And you see, we are talking also about moon now, not only about Mars. So the idea is to use an updated, or the part of this study is to update the phase 3D concept of the satellite, the bus structure, make the necessary modifications for flying to the moon and also to Mars. So the schedule we are talking about is a launch between 2012 and 2018. The best time to get to Mars is 2016. We missed the better opportunities already. So every 4 years you need less delta V, less fuel to get to Mars, and but the best year for it would be 2016. And because 2016 is still a long way to go, there was an idea expressed not by us but by the DLR to also include flying to the moon, having a spacecraft flying to the moon instead, or not only instead, but in the time in between. So on the moon we would go into an orbit 100 by 100 kilometers, and as you know, moon orbits are not stable, so we will have to take enough fuel. And the idea is that the spacecraft should still stay about 10 years in moon orbit. Similar thing with Mars. The planned orbit is about 20,000 by 500 kilometers, so in high elliptical orbit. In both cases, inclination is to be determined based on that. Will one of the things which will be coming out of this study. There are some ideas in particular for Mars, but regarding the kind of orbit, because we have Deimos is a very interesting place, and with phase P5A we would be the first satellite which comes very close to Deimos to make very close images, because it was clear that our spacecraft will not be better than, say, better than Mars Express. This is not possible. So we will be doing things which Mars Express isn't doing, and one of it is imaging Deimos, for example. So we will have various payloads, and as I said, the idea is a lifetime of 10 years. And so we have about 8 institutes from DLR in this study. We already had meetings twice, and so from various professions, including thermal design, mechanical structure, but also experimental the scientific side. So the result of this study, which is expected for the end of this year, and which will be directed to the head of the DLR with conclusions and recommendations, is then planned for January. And then the head of the DLR has to decide, are we going to moon, are we going to Mars, do we do both, or do we do nothing? That is the big question. Indeed, we hope it will be Mars. Also, all the scientists from DLR hope that, and they always said, why going to moon? Let's go directly to Mars. There's no reason for going to moon first. And I know that also some prominent Apollo, I think Buzz Aldrin also said, why not going to moon? Let's go direct to Mars. So anyway, so we have to see what comes out of this, and I think there's a good chance that we hope that we can make this mission. And yeah, I think we are running out of time, do we? Oh, sorry. So anyway, the rest of the slides I think you have seen before. Yeah, we keep our ZTL in Marburg. Also reduced it. No, I wanted to go to this one. So I think the conclusion of the session today is, yeah, P3 is still on track, but heavily delayed. And to be honest, I cannot tell you a launch date right now, because at the moment we do not have the money. We cannot buy a launch right now, but still we hope for the opportunity for a cheaper flight or a free flight, who will see. And with P5A it will also get indeed much better. But we still need your support. That's why I wanted to say, to keep P3 going on. I mean, P3 is real. The satellite is there. We are working on it. At the moment, not that hard as the years before, because at the moment we really concentrate on funding and the P5A mission. But we keep our laboratory in Marburg, we keep that alive. Also, we have reduced it in size, so it's not so expensive, and we need this to really go on with phase 3E. And so I still hope that sooner than later P3E will be in orbit, and hopefully together with flying to Mars. So sorry for my too long.
Thank you, Peter. Thank you very much indeed. But
Thank you.